All right, so we're now going on, and I just want to do this one again. NH4, all right? So what will happen is we will get two parts. We will get NH4 plus, we will get NO3 minus. So this one will gain a hydrogen, and it will form the acid on the left side. And this one will lose the hydrogen, and it will form then a base. So it's a strong acid and a weak base that's forming an acidic solution. So the salt that forms is acidic. So the salt here that formed was a neutral solution because it was strong. So what happened was here the Na plus gained the Na plus gained the OH from the sulfur, because the sulfur will form OH minus ions, and then we get our H2 that will form our strong base. So easy to remember. You break it up into the parts, you add your hydrogens here, either to this one you add it, or to the one you lose it. It's normally the positive one you add a hydrogen or a OH. To the positive side, you either add or lose a OH, OH, and then the negative side, you normally add a hydrogen. Okay, any question which you have here, guys? Ikhwani, Tafiwa, nobody?
No, sir.
Okay, let's go on then. All right, so now we're looking at, good afternoon, Samantha. So we're looking at acids and base indicators. So to actually know if something is an acid or a base, you get indicators. The indicator colors the color of the acid or the base, okay? So if we have this reaction here, we have hydrogen, and we add an indicator to it, we will get a specific color. If the indicator is an acid, if the indicator is a base, according to Le Chatelier, it will then change to a different color. This is just for interest sake. You don't need to know this by heart, okay? So this is also just for interest sake for you to read through. So we get different indicators. The main ones we normally use is methyl orange, methyl red, litmus, we get red or blue, bromophenol blue, and phenolphthalein. This is the ones we normally use. And then we get the universal indicator, which actually is the broad spectrum. So methyl orange indicator we use for an acid. It's definitely for a strong acid. Okay? So we will definitely use this for a strong acid. Methyl red, also we can use for a strong acid, definitely. Litmus is most of the time for a neutral acid. Okay, why? Because it will work nicely with a neutral acid. Right? Or we can also use it for if it's a weak acid, or we can also use it if it's a weak base, because the pH range is close to 7. The same with bromophenol blue. Okay, exactly the same. We will have a neutral, we will have a weak acid, we will have a weak base. Okay. Then for phenolphthalein, we will have a very strong acid, or we will have a very strong base as well. Okay, so this is important. So when we talk about indicators, methyl orange, strong acid, phenolphthalein, strong base. Okay, or methyl red, but we don't normally use methyl red, we normally use methyl orange. If we talk about neutral solutions, we talk about bromophenol blue. This is the three that they normally refer to. If you look in your exam guideline, this is the three that they will actually refer to also as well. So when you have a strong acid reaction, okay, you will use methyl orange. If you use a strong base reaction, you will use phenolphthalein. Sorry, yeah, you will use phenolphthalein. So this one is wrong. It's not a strong acid. I've made a mistake. And then if we use a basic or a weak acid and a weak base, or a strong acid and a strong base, you will get bromophenol blue. Okay. So you can see this is just the indicators. It normally has a nice bright color here. It's red, then orange going to purple and violet. Violet will be your basic solutions. Your orange and red colors will be your acidic solutions. Okay. How do we choose an indicator? You identify the strength of the acid and the base. Okay, so you will see, is it a strong acid? Is it a strong base? Then it means we need to use bromophenol blue because we're going to get a neutral reaction. Or is it a strong acid and a weak base? Then it means we will have a basic solution, so we need to use methyl orange. Do we need to use a weak acid on a strong base? Then we have to use phenolphthalein. Okay, so that is how we will work it out, and we will then indicate what is our indicator we used. Okay, so here we have an example. Which one of the indicators below is the most suitable to be used in a titration of ethanoic acid against sodium hydroxide? Very important, ethanoic acid is a weak acid. Sodium hydroxide is a strong base. Okay, so it will form a basic reaction. So definitely bromophenol blue is out, methyl orange is out, methyl red is out. So the only answer, the only answer that we will get is sodium hydroxide. I said now it's a weak acid. Did I make the wrong assumption? I just think I made the wrong assumption. I just wanted to quickly check. Sodium hydroxide is a strong acid. It's a strong base. And ethanoic acid is a weak acid. Yes, I'm correct. So there's definitely a mistake here in this example that I've given. Okay. So if you look here, our answer must be, we have a weak acid and a strong base. So it means we must be on the upper end of our solution. So they say here, we see ethanoic acid has a pH of 2.4, NaOH has a pH of 14, the midpoint between the two is 5.8, and that is where we get the methyl red. So they did it more scientifically than we actually did, but if normally they would give you only 3, so then your answer would have been here in the range of phenolphthalein or methyl red. The only reason why they choose methyl red is because they have the pHs. Okay, but if they didn't give you the pH, my guess would have been B. All right, so that's very important to look at. Okay, any question that you have? Any question that you have? So what did we learn this afternoon? Okay, so we learned this afternoon that we form different solutions. Our acids and base reactions are formed with salt hydrolysis. Okay, so we can then go and determine whether the salt is basic or acidic. Okay, so if you take the salt, you put it in water and you get your 2 ions, right? One of the ions will be more prominent because the other one will be the spectator. Then we will see we can get an acidic solution, okay? If you look at another one, we see we get a more basic solution. And that is where we determine if it is a acid or a base. Okay, so what did we see? We saw that a strong acid and a weak base is an acidic salt. Okay, so the pH is smaller than 7. We saw that a weak acid and a strong base forms a basic salt. All right, and when we get a strong acid and a strong base, or a weak acid and a weak base, we get a neutral reaction. Okay, then I just showed you how to form H2, or how to form an acidic solution with water, and how to form an OH, or a basic solution, in water. Okay, then we looked at our different indicators. We saw that we're going to use 3 of them in grade 12, mainly methyl orange, and it has an orange color. Okay, bromo female blue, it has a greenish color, so it turns either yellow to blue or blue to yellow. And phenolphthalein, it normally has this magenta color, a pink purple color, and it's giving us a basic solution. Okay, then we looked at the pH of each one. We saw how to identify it, and then we looked at an example. All right, so I'm going to send you now a quick question on how to determine whether we have an acid or a basic solution. If you can do that, I'm going to send you about 2 examples, or 2 questions. 2 questions. If you can indicate, if you can decide if it's a basic or a acidic solution, then you are done for the afternoon. And then yesterday's work you can continue with. So next up, we are going to look at acid and base titrations. And we also then, after that, we're going to start with how to make a basic solution, how to do concentrations, and we're still going to do KW and the pH calculations. All right, so guys, that's it for this afternoon. Is there any question from your side? I see Samantha this afternoon. Good afternoon, Samantha.